We will get started. So today we're going to talk about packaging, which is essentially just how you get programs to run on Linux. I'm assuming, is everyone here like a Windows or Mac user right now? Yeah, on Mac you just download like a disk image and then you like just drag it to your desktop and it just magically does some things there back then and then you have an app, right? Or has everyone here used Homebrew before? It's kind of similar to that. And then on Windows, usually if you don't like use, for the Windows people, do you use like WSL or? Okay, so then Windows essentially like there are package managers, but you've probably not heard of them. And usually you just download like a .exe, you run it, and then it downloads a couple things to your computer, and that's your program, right? But Linux works in a much more intuitive way to understand the full life. Like you don't really know what's going on the back end of like a Windows app that easily. I mean, it's very simple on the front, and then there's a lot of jumbled stuff on the back. For Linux, it's slightly, it's much more like you have to do like command line work, but once you understand like what's going on, it becomes much easier to understand the whole process. So first, again, just like to remind you of your course resources, you have us, your facilitators. Your head facilitators are Jasa and Kian. Unfortunately, they are not here today. We also have the EdStem and the Grayscope, as well as the OCF Slack or Discord on the channel DeCal General. All materials are going to be available at decal.ocf.io. Ask questions and work on the lab with us during lab sessions, which are going to be Tuesday 8 to 9 at the OCF lab. I will probably be gone for a bit, but like between then, but I might come back like in the middle of lab. Okay, so first we're going to introduce distributions and Debian, I guess, and then we will talk about packaging and then compilation. Okay, so first of all, who here has heard of a Linux distribution before? So everyone, great. So essentially, basically, like the distribution is just like the Linux kernel plus. Okay, sorry, I need to step back a bit. An operating system is Linux is not in and of itself an operating system. An operating system is the kernel behind it plus like some additional software. And in this operating system, you can then there are a lot of like different configurations on how you want the software to be. And one key difference, I believe, is the package manager. And that's going to be the talk of today. But essentially, there are a lot of different configurations. Each configuration is going to correspond to a different Linux distribution. And even within the same Linux distribution, there may be other smaller variants in configuration. So like comparing like Ubuntu with like your own like self-compiled version of Linux, both the similarity is essentially just that they use the same kernel, but all the software that's built around it is completely different, if that makes sense. Okay, and yeah, and there's also a lot of distributions. Like you can just take a look at this. Like you have a couple of like original OG distributions like Debian. I think up there's like Slackware or something, and then there's like a couple others down here. And then Debian branches out into a lot of different operating systems. And then this, I believe, is Ubuntu down here, which also branches out into a lot of different operating systems. Actually, wait, no, this is Ubuntu. This doesn't look like Ubuntu. No, this one is Ubuntu. There is just like one giant subtree down here, which is just all the Ubuntu distributions. It's even bigger than I thought. And then there's even more down here too. And then there's also this other big block over here is Red Hat, which is like a distribution that is made by that is funded more by the company of the same name called Red Hat. If you've heard of the distribution called Fedora, it's essentially like the open source like the completely free and open source version of Red Hat Linux. Red Hat Linux itself is like an enterprise operating system, so it's more meant for like business purposes, and there are some closed source elements. There's also further down, I think this is Arch, and then there's just a bunch more. Like if you've heard of like Gentoo or like Void Linux, those are all just their own branch somewhere down here. And there's just a lot of different operating systems. There's some like fill a certain niche. Some are just there as like some guy's hobby project that went too far, and everything in, and some are just meant for like general purpose computing and everything in between. So Linux is just the kernel, and there's very many versatile ways to work through it. So which brings us to the operating system that we are going to be using, which is Debian, which, if you see the graph, is the biggest one. So you can probably see why we want to teach this one first. Also, if anyone's tried Ubuntu in the past, has anyone? Yeah, that's essentially the same operating system, right? Not the same operating system, but they use like the same package manager, and a lot of the core is the same. So Debian debuted in late 1993. So it's a very old distribution as well. So why even use it? Well, first of all, stability. There is a new release every 2 years, and a couple releases ago is still like the operating system a couple releases ago is still being actively maintained. I think they maintain like up to like 4 years ago or something. Like two distributions, two versions above, and then it's also user friendly, which means it works out of the box, and it respects your privacy, which is like there are like things like Ubuntu. There are a lot of like pre-installed like spyware and bloatware that is good for a newcomer because it puts them in a more like comfortable experience because they provide a lot more services, but also like they come with the side effect of being like spyware. So Debian, you have a lot more control over what programs you're installing, which isn't as good for beginner users, but for like not really advanced users, but users who have like some degree of familiarity with Linux, which should be like every one of you after this class. It should be very simple to set up, and you will have a lot more control over your software. The naming scheme is also pretty cute. Like the current version is called Bookworm. Beforehand, it was Buster or something, and then before that, crap, I don't remember. I think it was I don't remember. But Bookworm sounds like a cute name. Oh no, Bookworm Bullseye Buster. Yeah. And then and it's also widely used, as you can very easily see. There are other distributions which may have their own merits as well. For example, Arch Linux is one that you've probably all heard about, probably in a negative context. It's always some guy saying like, "I use Arch," by the way. But why would you use that? First of all, like bragging rights. Second of all, they use like newer and rolling release software packages. So like if you try to open like NeoVim on like Debian, it's gonna give you like NeoVim like 0.7 point something, whereas on Arch you're gonna get like 0.9 point something. So the software, like the repositories aren't updated as frequently on Debian, so you're stuck a lot of the time with old software that may or may not work with like modern standard software. So you're going to have to be more mindful of that. Whereas for Arch, you're always given the newest thing. So when it comes to like it comes at the cost of like stability of the software, obviously, but sometimes people still want to have like what was that face for? Oh, sorry. Yeah, I thought you were confused by something. Okay, we're good. Okay. Or it's like it comes at the cost of stability, but sometimes you just want, if you're just a casual desktop user, to have like the newest software on hand. There's also very extensive documentation, which I think is pretty cool. There's also NixOS, which Adi, I think we're using that for like when we replace computers, right? Yeah, we are going to, but we're just talking about these. But we're using that for our like the new computers, right? Yeah. So even more bragging rights, and it's also much easier to like generate configurations for like a large array of computers because it's all stored in this one file, and that one file essentially has like pretty much everything like package and configuration related. So that's pretty cool, but these are not going to be the topics for today. So let's move back to installing software, which is going to bring us to package managers. So first, what is a package? Well, a package is an archive containing binaries and libraries of an application. So essentially, like, there's going to be a diagram later, so if this sounds abstract now, don't worry. It also includes some other metadata for the system about the application. and is used to install new applications onto a system. And to store packages, Debian uses the .deb format because it's their name, and that's cool. So if you can see here, so essentially the packages have a lot of dependencies. Like sometimes in order to like run, like let's say, what is something like NeoVim, you're going to need like to have something like you're going to need to have some libraries at the beginning that NeoVim might call, because when NeoVim runs, it's going to run through some stuff, and then as it runs through some stuff, there might also be some stuff that you don't have on your computer. So it wants to pull those in with itself so that it's never going to like run and then in the middle of it say, oh shit, I don't have something, and then like error out. So there are dependencies, and then those dependencies go into the packages, and the packages come with their metadata, which is essentially like what version you are, and a couple of other things like that. And all these are stored in a repository, which essentially has a repository like of packages, kind of like how a Git repository stores all your files, right? And then from the repository, the package manager gets all of your files, and the packet gets all of your packages at the least. And from there, the package manager then packages them, and puts them into the user system as like by essentially separating all the binaries, the libraries, and the executables. Right? Okay. And why do we need to use a package manager? Well, first of all, packages, would you trust, like, if someone just gave you like a .exe file and told you to run it, would you like trust them with it? Yeah, for sure. So essentially, the packages are reviewed by like a certain group of people who essentially their entire job is just to maintain packages, ensure that they're up to their latest quality and security, and thus there's no need to like manually configure any options. So this gives us a fast and easy way to install and update the users, install and update for the user, because verifying every single executable you get and configuring every single executable you get to work the way you want to is going to take a lot of time. So as such, packages often also get updates and security patches, just kind of like every app that you know. But packages and apps have some key differences. Well, while an app is essentially like the developer pushing an update, the package is more like being maintained. Like people can just push forward updates, and the maintainers will be like, yeah, that sounds good, and then just do stuff with it. Packages can also depend on other packages, so it's like you cannot run this package unless you have that package installed. Users also trust the distribution not to package sneaky software as part of the vetting process talked about, whereas for apps, users just have to hope developers won't be sneaky. There are other packaging methods that we won't talk about today, such as web apps, snaps, and flatpaks, which are kind of like the app format for desktop Linux. Helm, which is packages for Kubernetes, which I think we'll get to later. Arch, by the way, we're not talking about that. If you want to learn about it, come back without showering for 5 days, and I'll tell you. Homebrew, it's like a cross-platform package manager for Mac and Linux. It's pretty it's just there, I guess. We might actually end a bit early, so you want to take over for this part? I'll come back in a bit. Yeah.
All right, so I guess now that you know, like, what was the previous slide? All right, now you know like how packages are and like what packages are and how to use them. So now we're gonna like talk about how to use them specifically. So apt, which stands for I think aptitude, is the particular package repository that is used, or it's a repository of repositories, which are basically these mirrors to these different softwares. And in this case, apt update will actually just pull a list of all the available packages from the repositories that are listed. And then when you do install, you're basically installing the package. It's running the entire like installation sequence. And when you do remove, it's doing the same thing except removing it. So in this case, distribution upgrade will update the packages and resolve packages conflicts and removals within the system. Search, you can obviously use search to figure out like which package you want to download, different versions available. And yeah, there's like a bunch of, and this is like the way you install things locally. So essentially what apt is doing is that when you're running apt install, it's downloading this Debian file and then running this like, and running install on the local Debian file, but it's just in a temporary directory that gets like deleted right after the installation is done. But if you really want to build your own package, you can actually just build your own package and then just run like apt install with the / to make it run in that directory. So I guess like in this case, a random package that we're going to talk about is calsave because it just prints out like an ASCII version of a cal saying something. So apt install will basically just read from the list of all the packages that we have, and it'll find out what dependencies the package needs. And it basically checks to see what dependencies the package needs, and then it sees if the system has all of them or what it's missing and what it's not missing. And then it will download the packages, and then it'll do like a SHA-256 like checksum. It'll find to see if the checksum matches to verify that there wasn't like a man-in-the-middle attack to make sure that like the package that you download is actually the package you want, and it's like the one officially licensed from like the repository. It unpacks them, then it processes any remaining triggers, and triggers are basically just scripts that run post install to see if like there's checks to see if like the service is started or if like the application was built properly. So some packages require like will actually download and like will compile using make or CMake or some version of that. And because they compile during make, if there's a compilation error when it's built, because all the system objects weren't fully linked, that's when it will detect if anything is not working. Oh, so for example, this is just like a list of like some of the repositories that exist. So like apt sources like list, and then there's like list.d, like a bunch of all of these different repositories, and these repositories are all the different like softwares that you can possibly download. So like I guess apt is just a package manager, and all it will do is check this list of repositories to see if the package you're looking for is in one of these repositories, and then it will download them. So I guess like this is kind of so feed into the lab and create your own package. So essentially, you have source code, you compile it, it turns into an executable, and you package the executable into like a Debian file, and that Debian file is like what you would be downloading using apt. So I guess in this case, the compilation stuff is literally like the output. So in this case, it's like if you use GCC to like compile a C file, you usually get like a dash output or dash out or dash o file. That's an executable, and that's kind of what is used for like to create the executable that's then packaged. And as you can probably tell, when you have like one file, this is doable. When you have like a bunch of files and you have a bunch of outputs because they're all linked objects, it kind of becomes messy. So there's like then you use like make, as I mentioned earlier. Basically they basically like make files are a list of steps that that the software will take to build a package. And in this case, compile like GCC or CLang for that matter. Basically you run /configure, and then that will like I think do some pre-install stuff, and then make install will end up basically compiling it, and make install will actually be linking that to your system objects locally. So then we're talking about the package section of it. Yeah, so packaging is like a huge pain in the ass. It's kind of like the best way to think about it. Basically, you have to download software, write it, make sure everything's configured, and then you check the dependencies and the metadata to see if it's actually the same. And then you have to link the libraries, which is like linking to system objects, which is like what the system assumes is a file that. I guess the best way to explain a system object is it's like a system link, a symlink, a symbolic linking rather. So it's basically a link to. It's basically the system linking to a specific file or directory, which this file also exists. So we're going to use the effing packages. I have no idea why it's named this. But it's basically a Ruby gem, and it makes it less painful. I've never used them particularly, but I guess we're using like use gem install for FPM, and then you basically just run this long thing. And this long thing essentially probably will build the package into a Debian file. So okay, this is probably more standardized. This is like a Debian file, and like this is like what a Debian file consists of. This is kind of like the layout. Inside like the dash user, like there's always going to be like the header files, the libraries, executable binaries, documentation, and the metadata. This is standard for almost every Debian package you will download from like Aptitude or like I think Pacman it is for Arch. This is kind of standard. Like this is, I think this is kind of what we do in the lab as well. But like, yeah, every single like, if you were to extract, go download any Debian file, you can just like right click and extract it using like not 7-zip is Windows, but like, I don't know, like, is it like fzip or something? There's like some like command line tool to zip or unzip on Linux, and you'll actually see like every single time they'll always have something similar to this where they have like binaries, libraries, headers, documentation, and the metadata. Yeah, this is just like a tree view of that. So like it's basically the same every single time. Bin shared documentation, you have like all the locality stuff, and then you have like the original file itself. Okay. Yeah, this is like a demo, I guess. So I guess when we download the Debian file, we use like app download or wget, and then breaking it open, you can use AR to like actually examine the files and like unzip it, I guess, in this case. And yeah, I guess these are different ways that you can like open into a Debian file. So basically Debian files or .deb files are just archives, and like with them just being archives, you can just download them and you can just like look into them like this. And I get the star means like any version in this case. So the control is the package metadata of a Debian file. Basically, is the size of the package, the version of the package, and then like the dependency this package also needs. And that's and all these are basically standard. Like I guess we talked over this, like the man pages, locals, documentation, the configuration files, the checksums. This is all standard stuff that like every Debian file has. So like if you can take a Debian file, like if you want to download it, like you have like Linux or something, and you can have the same thing, just different versions. This is like I guess the documentation of resources that might be useful for the lab right after this. I think we're done. You guys have any questions? I think y'all can look at the lab. I think also these slides will be posted because the slides have like the links to documentation, but like it's used for a lot.